One of the most common uses for u-substitution is just to keep track of what happens to a constant inside a function. So for example, if we have the antiderivative of the sine of 3x dx, if we let u be 3x, that's our inside function, then du dx is plain old 3, or du over 3 is dx. This is a way of seeing that in fact what we have for the integral of sine of 3x is 1/3 of the integral of the sine function. We're going to let you use the letter u this time. And this is 1/3. The antiderivative of sine, well, let's see, the derivative of cosine is minus sine, so the antiderivative of sine is minus cosine, plus a constant, and that gives us minus cosine 3x over 3 plus a c. Now, in practice, we usually do this substitution in our head. If it's simply a constant times x, we remember that we divide by the constant because we're using the chain rule backwards. Okay, one more example, and this one's a little strange. Sometimes u-substitution is used to move a sum or difference to a more convenient place. Let's take a look at the antiderivative of x over the square root of x plus 1 dx. The only inside function we have is x plus 1. The problem with that is that du dx is 1, or du is dx, and what causes a problem there is that we have this x left over. That's going to be the square root of u, that's going to be du, and we still have an x sitting around there that we can't substitute for. What we do is solve it. If u is x plus 1, then x is u minus 1. This gives us then the integral of u minus 1 over the square root of u du. Now, the reason this is better than this is that here we can break up the fraction because our plus or minus sign is in the top of the fraction rather than inside a square root. So we can write this as powers of u. This is the integral of u to the 1/2 minus u to the negative 1/2. How'd that happen? U divided by the square root of u is the square root of u. 1 divided by the square root of u is u to the negative 1/2. Or we could think of multiplying through by u to the minus 1/2, either way you want to look at it. Now we can use the powers rule separately in these two cases. U to the 1/2 plus 1 is 3/2, so we've got 2/3 u to the 3/2 minus u to the negative 1/2 plus 1. Let's see, negative 1/2 plus 1 is positive 1/2. So we have 2 u to the 1/2 plus a constant. And then we substitute back in, and we have 2/3 of x plus 1 to the 3/2 minus 2 times x plus 1 to the 1/2 plus a constant. Now there's a dozen different ways of rewriting this. You could factor a 2 out of everything. You could do something involving square roots and combining, or you could factor out an x plus 1 to the 1/2 or whatever. But this is basically the answer.